Okay, you can maybe Tony start. Tony, you can take over.
I hope you guys can hear me.
Yes, I can hear you, but I think you are far away from your mic.
Okay. Let me try and change my internet then.
No, I think you are audible now. Hi, Tony. Sorry.
Hello.
Yeah, I think it is fine.
Can you guys hear me? Am I audible enough?
Yes, yes.
Sir. Okay. So let me. So no, the project was about the analysis of the Walmart sales. Joseph was the one who took the first part of it and introduced us to the project. And he started by importing the libraries, which are the pandas, as PD, NumPy, and matplotlib.pyplot. The matplotlib.pyplot library is used for now the manipulation by getting to analyze your data in terms of plots and graphs. Seaborn as SNS and went by importing the data into our into our Jupyter notebook, which is which we assigned our data the data from the data frame DF. Then we read the data. We had saved the data in our local machine as walmart.csv. You have to note that one. By exploring the 5 rows of the data, the df.head with open and close parentheses was able to give us a brief view of how the data is, which is the store number, date, weekly sales, holiday flag, temperature, fuel price, CPI, and unemployment. By getting to do that, you also have to check the info about the data. This one is whereby you're trying to explore more of your data to get to know what the store column and the values under it, what are the data types under it. So now the data type under store was an integer, the date was an object, float, only the flag was an integer, temperature was float, fuel price was float. The reason as to why temperature, fuel price, CPI, and unemployment of float is because there's the involvement of decimal values. As you can see above, the temperature, like for store which is in a row number 0. In Python, we start naming the rows from 0, 1, 2, 3. We don't start by 1. So if you check out the row here, this row, you'll see that the temperature was 43.31. If it was 42, then it will be an integer, but since it's 0.31, it's a float. The store categorical variable represents the store number, date, the week when the sale was made, weekly sales was the sales for the given store, holiday underscore flag whether the week is special holiday, temperature was the given week, CPI. So now we got to see the categorical variables were store and holiday flag, while the numerical variables were weekly sales, temperature, fuel underscore price, CPI, and unemployment. So under the data preparation, we had to check for the missing values, check for the outliers, check for the duplicates. This one is used to help you not to have to reduce the noise in the data, whereby you could be having duplicates, missing values. We'll see down below where our missing values were, whereby we plotted an histogram, and we noticed that there were some missing values, which brings a very interesting scenario here, because when you were checking for the null values, there was 0, but when you were plotting it, we noticed that there was a missing value. It's a case study for us now. We checked for the duplicates by the df.duplicates.sum. Remember, we are using df because the df is the one that we used to assign the Walmart. If you could like, you could even have data here, but remember that you'll be using data everywhere, and otherwise you'll be getting the error. Even any, you can assign the variable for Walmart any of which name you like. So we had the df.duplicate.sum to go there was 0. Duplicate df. Is null, which was used to check for the null values. .sum to get the sum of the null values in each column. We got 0. Then we checked for the outliers, which Joseph did here for the outliers, whereby we were able to get the outliers for the weekly sales, temperature, fuel price, CPI, unemployment, weekly sales, temperature again, fuel price, and CPI again, and unemployment. Exploring the variables in the dataset individually to understand its distribution, summary statistics, and any patterns. For numerical variables, we will calculate the measures like mean, median, and standard deviation. So like in the case of, let's say, temperature, if we would have gotten like the some null values in the case of temperature or fuel price, we could have used the mean. The mean is whereby we get the mean of the temperature for the whole. Then we can replace the mean by with the value that was missing in that column or the row. So for numerical variables, you use the mean, but for the categorical ones, you can use the mode. We start by examining the data set structure using df.shape to get the number of rows and columns, df.columns to obtain the variable names, and df.info to provide summary information about the data set, including data types and null counts, which I've also explained above. Next, we check for missing values, which is df.isNull.sum to get for the count of missing values in each column. We then focus on exploring the numerical variables by selecting them into the numeric underscore vars list. We use df.numeric underscore varchar for describe to compute summary statistics such as count, mid, standard deviation, minimum, quantiles, and maximum for these variables. Similarly, we explore categorical variables by selecting them into the categorical vars list. Okay, now we have to explore the data here by using the numeric underscore vars, which was weekly sales, temperature, fuel, CPI, and employment. Then we had to describe the data. Now by assigning numeric dot underscore vars, we were able to have in Python whereby the list. Now here it was our list. Our list was weekly sales, temperature, fuel price, CPI, and unemployment. You have to give it the list, then assign the list to a variable, which is numeric underscore vars. Then print the list with a description to explain to us the mean, standard, Standard deviation, uh, the max values 25, 50, and 25, and minimum. Then further we explore the categorical variables, frequency of each category, which is done there. Uh, then uh, then we print the specific variables, which we also did there. This is part of the EDA whereby you get to maneuver between all the EDA processes to explore the data and manipulate it more and understand more of it so that you can draw meaningful conclusions when you're going even to select the type of model you're going to use for machine learning for your predictions and forecast. So the histogram here, we were able to plot the histogram of weekly sales. It was okay. But then you notice here that the 3.5 here, there's some missing value or it's a 0, which is also an issue. We need to go back and explore more of the data. The case whereby I was saying that we had a missing data is in the CPI one, whereby when we were checking for the null values, we didn't get to see there was a null value in the CPI, but here we are plotting it, we're getting to see a null value. Then we plotted for the unemployment, all this by exploring the data, and then we did a scatter plot, and then we did the box plots. The box plots didn't come out well because they were not explainable well. Then we did a heat map, whereby we were able to get the positive and the negative one in the heat map, and which is the correlation was positive, and like you could see here, the correlation between temperature and weekly sales is one. Yes, that was it. Yes, Xavier. Xavier, anything you need to add on? Hello?
No, I think we can proceed with what we are supposed now to cover today, because that was just a recap.
Yes.
Hello?
Yeah, I can hear you, Xavier.
Yeah. I think we can proceed with what we are supposed to cover.
Okay. So let me first restart my.
Hi, Xavier. Hi, Tony. I have a question.
Hi. Okay.
You mentioned that you were able to identify that there were outliers in the data.
Yeah.
How do we deal with that in terms of do we consider them as we are building the model, or do we remove them completely, or what is the best way to handle them?
The outliers are able to help you out in exploring more of the data. So when you're doing like a feature selection, you're able to consider them or not consider them. Have I answered your question? Xavier, do you have anything to add on?
No, basically that is what you do to the outliers. It is only the missing values that you can replace using other methodologies, as Tony explained, like using the mean, using the standard deviation, and so on. But outliers, it doesn't mean that when you have the outliers in your data, it doesn't mean mostly that it is something wrong to have, but you can use it. I think maybe we will tackle the feature engineering and so on and see how they can assist us.
Okay.
Okay.
Okay. Thank you.
think we're good. So for this project, I chose a random forest regressor for it, but it's for the startup. We will continue getting more of the ML models to get to see which one will give us a nice MAA for it, or the one that will give us a better performance. So I'll start by importing the necessary libraries. So from learn dot ensemble import random forest replacer. Import and as the and we import maybe
Maybe Tony, as you are continuing, because this is a community learning forum that we all contribute and so on. Uh, I understand that we might be at various levels of understanding and so on. We have those that have completed the entire curriculum. We have those that are still beginning and so on. Maybe it is good to be trying to put more comments on what you are doing. Like when you are talking about importing these libraries, why are you importing? And where are you going to use them from? Like to explain each step so that for the purpose of enhancing understanding. But as I said, this is a community learning is an open forum for each one of us. You can always raise up your hand, contribute, and so on. It is a learning process. That's what I wanted to mention, Tony.
I don't know why it's on giving me the autofill. I'll have to switch to collab. Let me try once more. Just a minute. Let me switch to collab.
Okay.
So yeah, import libraries. And we import import. I don't think we'll need the matplotlib here. Let's import the import SNS. Set. Yeah. So since I'm going to use Colab, I'm going to mount first my driver, and I'll have to have the library here. Import drive. Then the warnings, I'm going to ignore them. Warnings. Warnings. Filter. Warnings. I'm going to run my code here. Can you guys hear me? I don't know whether my internet is fine. Maybe confirm.
Yes, I can hear you from my end, Tony.
Okay. So then
maybe just to explain what Tony is doing, like in Python, for those who maybe haven't read there, we have different kinds of IDE development environment. We have the cloud-based, like the Google Colab, and we have the Anaconda, the one that you install in your desktop and so on. So what Tony is doing, that he has switched off to the cloud-based kind of IDE. Yeah.
So then I'm going to mount my drive. Sylvia, can you hear me? Hello.
Yes, I can hear you from my end. Just proceed.
Okay. Yeah. I've had a blackout, so I had to switch internet.
Okay. Sorry for that.
Then I'll have to mount my drive, which is a content drive, and run my code. Then it will give me an authorization window to use which drive. Then I'll allow. So this happens when you have your data in the drive and you want to use Colab to access your data, and you want to use the drive to access the data through Colab. You have to mount first your drive, then you have to define the path and access your data. So a file path equals to content drive my drive. Now the source whereby the name of your data in the drive. I named the name of my data in the drive as Walmart.csv. Run it to confirm. Then I will have to assign my data with the data frame pdf, which is then read the data using the pd.read CSV. And because we had assigned our path by using the file path, we're going again to use it here so that we can assign our data frame. And running it to confirm if it's the data we have, and print df.head, print the first 5 rows of the data. It's just for the confirmation. And we have the store, date, weekly sales, holiday flag, temperature, fuel price, CPI to confirm it's the same data. Okay. So moving forward, because we are going to be using libraries that are involved that machine learning, we love to import first the libraries, which is sklearn, pandas. Of course, we've already imported pandas, because the sklearn.model_selection, which is used to train and test the split from sklearn.ensemble import random forest bracer. Then we've already imported the pandas, so we'll have to import another sklearn ensemble library from sklearn.ensemble import already imported sklearn.model selection, and we'll import the one that will help us to test and split the data. Train for test for split, and from sklearn.metric.
I can't see your screen, like any movements. I don't know if it is my internet or the rest of the teamers. Like the last part I can see is when you are importing sklearn ensemble. Is that where you are?
Anyone else to confirm that? Anyone else to confirm?
That's okay. It's now loaded. It was stuck.
It was stuck. I think it's my internet. I have a blackout.
But it's loaded now.
Okay.
Yeah, now it's okay.
And my location kunanyesha. It's loaded. Save your confirm.
Yes, it is fine.
Then we'll have to run it first. Without incurring any error, we proceed. Now here we proceed by splitting the data into features and target variable. By splitting our data, we have to split it so that, because going to the one who had asked the question of outliers. Now it's where by the exploration of your outliers in the EDA, and each column in the EDA, we were able to identify like our target variable is weekly sales. So now, meaning our features are like the store, temperature, CPI, unemployment, holiday flag, fuel price, and date. Okay. And in machine learning, we split them with the variable X and Y, whereby the X is usually the one that carries the features, and the Y carries the target. Are we together? Can you guys hear me?
Yes, we can hear you.
Yes. Okay.
Yes.
So we split it by X df. Remember, df is the one that we had assigned here. Don't forget. You can have data, you can have anything else. df, and our features are in a like a list format. We'll have store. You keeping note of the caps. So we had temperature. We had a CPI. We had lead the flag, holiday underscore flag. We had fuel underscore. Then we had fuel underscore price. Make sure when you're giving them you're listing them the exact way that they're listed in your data, especially about the caps and spelling. Don't leave out the underscore just because you can leave it. Then we add date. And we add date. And for our y, which is at the target, df weekly cells. And we run our code. We have an error, temperature, not in index. Temperature to temperature.
I think in the spot temperature.
Yeah. Okay. Thank you.
Then also maybe if I can add something on the X and Y.
Okay.
Remember we were, sorry Tony.
Okay.
Can I proceed maybe to add something, some more information?
Proceed.
Okay. So you see the weekly sales is what you are predicting. That's our objective in this project. We want to predict the weekly sales. And therefore that mostly we assign we assign the y the y axis or the y variable and so on. Okay, you can proceed, Tony.
Also, to add more on that, to determine the features and target variable in a data set, you need to understand the problem first. You're trying to solve and the relationship between variables in your data. Some of the general features are like you have to know the general features that are used to make prediction or classify data. Then you also have to know the independent variables or input variables. Like in this case, further, we'll have to have a case scenario whereby you're able to put the temperature, CPI, and only the flag to have like a forecast of how the model will work out and how it will predict more of the weekly sales. But I also think that it's important to note that the determination of features and the target variable depends on the specific problem. Yeah. Okay. Now we proceed. Let me add a new cell. So after doing that, first of all, I started by converting my date column to a string format. This is the reason as to why I want to convert my date column to a string format. It's for in many machine learning models, the input data is expected to be in numerical or categorical format, and also dates are typically represented as strings, need to be converted into a suitable format before they can be used as features in the model. So by me converting the date column to a date time format, I was able to extract additional information from the date, such as the year, the month, the day, weekday. which can be useful for features for predicting the target variable. So this is what I did here. I was able to convert it fast, which is x data equals to ed dot to underscore this time open parentheses at and earlier, which is caps, then it eight, and we run our code. X is not defined. Okay. X date.
So I think you are using small x. So change your x to small x instead of
To
capital
change
X.
my X to small x. Okay. Okay. Oh, thank you. That's the code of converting it. Then I will be able to extract now the additional features for the data, which is x year. Additional features will be the year, month, day, and weekday. So the year is equals to x is the date dt. We'll do the same case for the
Hello,
day.
I can
Day.
see your screen updates. Yeah, I can see them now.
Okay. I'm having a slow internet because I have a blackout, so I'm using the mobile hotspot. So
Yeah, I can see your updates now. You can proceed.
okay. No further, we'll be able to edit this code for our else month dot month dot month an error, which is day dot dt dot day. We'll have weekday have an error again. Yeah, dot. Okay. Here we'll have to have a brief explanation, which is a extract additional features from date. From it. And we run our code. After doing that, we proceed down by, because in this case, I guess after extracting the additional features, we won't need the date column. What do you guys think? So what do you think? Should we drop the date column?
Yes, I think the date column should be dropped.
Yeah, it should be dropped. So we use the dot drop code to drop the date column. X dot drop date. Yeah, it was successful. Look the date column. Use noise. That's okay. The question up to that point. Save any add-ons.
I think currently it's okay.
So far, so good, isn't it?
Yes.
So the next thing, yes, it will be splitting our data into the training and testing. In machine learning, we split our data into the training of 80% and testing of 20%, which is denoted by 0.8 and 0.2 respectively. It is the common way whereby we expect most of the data, which is 80%, to be used for training, then the 20 to be used for testing. But in your case, if you want to change it, you can use the 70, 30, 50, 50. But for getting the nice outcomes or drawing meaningful conclusions, we split it by 80 by 20, which is 80 training, 20 testing. So we split our data, which we use the X train and X test, Y train, Y test. So X underscore train X underscore test Y train Y test and Y equals to train underscore test split be splitting X and Y test underscore size 0.2. 0.2 meaning it will be 20%. Now our random state will be 42. Our comment here will be splitting into training and testing. Maybe a question to you guys: why did I use the random state to be 42? Anyone with a clue? Anyone with a clue? And why not 50, 60, or 70? So we used 42. I did choose to use 42 for the reshuffle. Random state will be 42 because the number of 42 times I want the data to be reshuffled during the testing and training. So, save any add-ons? Anyone want to add more of the random state? Hello?
Hello. Yeah, we can hear you. So what I think is 42 is just the answer to someone who was working in machine learning. Yeah. So 42 is just used to like generate let's say a unique random set of test data that we are going
reshuffle.
Yep.
Yeah. Anyone wants to add more on the same? Anyone? Okay, let's proceed. Then my next step will be initializing the random forest regressor. Comment here. Initialize random forest regressor. In this, I just say the model is equals to random forest with the n the n estimate of 100. Estimate of 100. My random state will still remain at 42. Why did I use the n estimate as 100? Anyone with a clue? The one who has been talking. I see you're good at ML. Why did I use the 100 as the n estimator? Why I use the 100 as the n estimator parameter? N estimator is the number of decision trees to be included in the random forest. A summary of it. You can go read more on it. So, because the choice of the specific value of the n estimator depends on various factors like the size, complexity of the data set, the availability of computational resources, and the desired trade-off between model performance and training time, I guess. So in this case of ours, 100 was a relative common choice. So let's move on. So moving on, I'll train the model. So train model. The model.fit x_train train. We run our code. Yeah. Set. Prediction of the test set. Of the test because we had split our data into x and y, so our target variable was in the y axis, and the features were in the x axis. So when you are trying to predict, you'll have to use the y. Predicate parentheses x Yes. We have an error. Oh, predict. Any question up to that point? Any question? Save any question? Xavier?
I think we have no questions.
Okay. So for the random regressor, we'll have to find our mean absolute error. By finding our mean absolute error, we're able to determine I'll say the efficiency of our model. Okay, so our mean absolute error. So finding the mean absolute error. So mean absolute error MAE is equals to mean absolute error is y test y because I wanted it to be in an whole value. I'll have first to divide it by 1,000. Rounded may equals to int. This is an integer. In absolute error, the value is in an integer. 1,000. Then print it. And I'll print I mean absolute error. Error. Rounded. May. Then I'll run it. I'll get 67%. That's the end of the presentation for today. You could choose any. You could even use 100. Yeah, even use 1. Whereby you'll get all these values, but well into a whole number that will be measured. 100 to 67. Sorry, you can take over now.
Okay, maybe I can give my comments, then Joseph also can give. And I think so far it is a good trial, Tony, given that you are still in the process of learning and you decided to take a challenge by taking guys through this project. One thing maybe that I want to comment about, still I want to insist on the issue of, like, you have to be able, not Tony alone, but anyone else who will be taking other projects. I know this one we are still working on it, but any project you need to explain more, like whatever you have been. Like for instance, you haven't told us, Tony, why did you decide to go with the random forest and not any other machine learning model, and so on. So those are the comments that I can give. But so far as a beginner in this area, I think it is absolutely a very good trial on your side so far. Maybe my colleague Gitao can also give some comments.
Thank you, Sylvia. So I think, Tony, you did a good work. So what you've done is great, and I think it covers mostly what you've been taught in class. Yeah. So can you share the link to this notebook? Maybe I want to add on a few things before we can end our session for today. So maybe you guys can give me 20 minutes, then I'll have to explain a few things that have been done here.
Okay, I think that is fine.
Yeah.
Yeah, Tony, you can share with Joseph. And
Just share the link. Don't stop sharing. Don't stop presenting first. Share the link to the notebook and also ensure that you've given access to view. Yes, I'm sharing my screen. Just a minute. Okay, so someone to confirm if you can hear me.
Yes, we can.
Okay, just a minute. So I'm not sure if we've gotten the link to the notebook, but I think I can also start afresh, though I will be fast while doing that. Okay, so here I have my Jupyter notebook, so where I'll be doing all my codes. So we have the walmart.csv data, so I think everything is okay there. So I'll first start by importing libraries I need. So libraries, and we start with pandas. Let me zoom in a little bit so that you can see my code. Okay, I'll import matplotlib. I'll also import Sibon. Then I'll import warnings. Then I'll have to ignore all the
Joseph,
warnings. Yes.
I've shared the link.
Okay, just a minute. But I think I can still use this. Okay, so after importing the warnings, let me import the data. So we'll have bf equal to pd.read underscore csv. And here we have walmart.csv. So I'm going to skip a few words. So, and I'm just going to have bf.head just to view the top 5 rows. Then I can do the pre-processing that we want. So the first pre-processing that we need to do is convert the date column. So here we will extract our A. So what else did you extract? One, and here from the date column.
Day,
So
month, yeah.
that's what we'll have. Okay, so for me, I'm using a split. So x dot split, that. So let me confirm if that function worked. So bf it then 0, 8, 0, then I just want to index the first item. So this is the first item, so it's a string. Then if I type in dot split, then I split on a pad. This is what we get. So this is the I think this is the month. This is the day. So here we'll extract. We will extract the day. We'll extract the month and the year. Okay. So that's for the day. I think no. So this will be the day. 0. That's for the month. That's for the year. Okay. So let me get the link which was shared. Then I'm going to share my screen. So instead of doing this afresh, I just want us to save on time so I can explain a few things. Okay, so Tony, you'll have to give me access to that note. So I don't have access to the note. Okay, I'm resharing my screen. I think we'll finish this first. Okay, so here I will drop the date column. So I've created the day, month, and year column, and I've converted them to integers. So I'll have to drop the date column. So I'll have df.drop date, then in place should be equals to true, so that I don't have to like do the change everywhere. Okay, so after I've dropped the date column, so I will create
Yes,
x.
mini access.
Okay. I'll create x and y. So x should be equals to df.drop weekly sales, which is the target variable. Then our y will be equal to the weekly sales column. So yeah, when we are working with this data, so this is the most essential part. So if I type in df.head, so this is where we define our machine learning, and we have to answer a few questions. And the first question is, what kind of target variable are we dealing with, right? So is it a continuous or is it a continuous variable, categorical, or binary? So something like that. So once you've answered this question, you proceed on to the next part. So and answer the question. So what kind of model will we use? So is it a linear regression model? Is it a clustering model? And things like that. So if we have a look at our data here, so the weekly sales column. So the weekly sales column is a continuous variable. And this means we'll have to fit a regression model. So, for, so here I'm going to say we are going to fit a regression model. And for regression models, we have the most popular regression, the most popular regression models are, okay, so we have random forest, we have, okay, so apart from random forest, we have decision tree, and we have gradient boosting. Okay, so those are the three most popular regression models. And I think Tony chose the random forest model. So next, after you've figured out the kind of model you want, you have to split your data into training and test set. So I'll have to specify my test underscore size here to be equals to 0.2, same to what Tony used. Okay. So now we have our train and test set. Then I'll have to import my models, right? So I'm going to import random linear regression. So that will be our baseline model, decision tree regressor, random forest regressor. So let us use those three models. Then here I'll create a function to fit and score the model. So we will have df fit and score. So we will have the model that we are going to fit the data for. So I prefer using functions so that I can eliminate the need for like doing these steps here. So we will have our model being equal to that code. So this is the documentation. So fits and evaluates the model. So here you have the variables definitions. Yeah. So we have something like that. So let's run that. Then we have to create a dictionary of the models. So these are the models that we have. So we have linear regression, we have our decision tree model, and lastly we have our random forest model. So next we fit the models, extract the scores. So let's run that and see what we get. So I'm going to again fit a single model, then I'll explain to you the steps of fitting a model. So you can see the reason as to why I was saying decision tree and random forest are the most popular. So linear regression is just the basic model that we have. And we can't fit gradient boosting as of now, but we can include it if you want to. But you can see linear regression is one of the models. So as I had mentioned, I was importing this library as for this model to be our baseline model. So you can see linear regression model has an R squared score of 0.15, which means it explains 15% only of variability in the data. For decision tree and random forest, we have 94% and 95%. So you can see the reason as to why these two are the most popular model. So let's fit a single model over here. So we'll have let's do a random forest, what random forest regression. Then next we instantiate the model. So to instantiate the model, you'll have to copy this model that has been imported. Then you'll have to create a variable. So I will have a ref being equal to random forest regressor. Then I'll open brackets. And in here, we have things we call hyperparameters. So you can add hyperparameters in there. So for example, number of estimators. So Tony had mentioned to you that the number of estimators are the number of trees in the forest. So you can add hyperparameters there if you want to, but I'm just going to leave it blank as of now, since I'm just explaining this to you guys so that you can understand what this means. So after doing that, you feed the model to the data. So you will feed a ref, which is the instantiated variable. So which is the variable storing the instantiated model over here. So we will have rf dot feed, then we feed on the train dataset. So here I'll add a comment and say we always feed on the train data. Okay. And the next thing you do is you make predictions. So you'll have pred being equal to rf.predict, then you predict on the test data set. So always make predictions on the test data. Okay. So after making predictions, the next thing we do is we evaluate the model. So evaluation of the model. So to evaluate your model, you'll first have to answer some few questions. So what kind of model did I fit? Yes. And what kind of metric is appropriate. Okay. So for regression models, so for regression models, the most appropriate metrics, we have the R squared score. Then we have the mean absolute error, MAE. We have the mean squared error. And I think we have another. So we have these four. So we'll import these four and we will evaluate that model using that. So I think for the R squared score, this is what we use. So for the R squared score, we just type in rf.score. Okay, so can you see that? We just type in rf.score. But so here we will import from scaland.metrics, import mean absolute error, mean squared error, and score. So we don't need that because already we can use the rf.score to get that. So we need the mean absolute error and the MAC score. Then here we can get the MAE. So we just type in mean absolute error, pass in our Y test and our Y print. So note here, for rf.score, we are only using the X test and Y test. But for the mean absolute error, we are getting the Y test and the Y print. Why is this so? So what we are doing is we are comparing the distance between the actual and the predicted values. So for mean absolute error and mean squared error, we are using the distance that is there in between the actual and the predicted values to evaluate our model. Okay. So I'll have to add print statements here, but we can see the outputs of these runs. So I'll do a print here also. And I'll also add a print here. Then lastly, we have the RMSA, which is the root mean squared error. So we had imported NumPy, so we'll have np dot square root of the mean squared error. Then we can run that. So here you can see we have the different scores. So I'll leave the interpretation of these scores to you guys. So you'll have to like dig in deeper and research more as to what these scores represent. But if you need help with that, I think we can discuss that more on the group. So those are the few things you need to focus on when creating your model. So the first thing that I have mentioned is understanding your target column. So what kind of target variable are we dealing with? So is it a continuous, categorical, or binary? So if it is continuous, you've seen we do a regression model. If it is categorical, we do a classification model. If it is binary, we also do a classification model. Then what kind of model should we use? So I've explained. Then the next thing, so after you've identified the kind of model to use, so which are the most popular models with the best scores out there? Yeah. So pick one. So I've picked two, so random forest and decision tree, created a function to fit the model. And here you can see our results, right? Then next we've created a few questions as to what kind of model did we use, what kind of metrics are appropriate for evaluating that kind of model. So that's all you need to know. So a bonus will be to check if the model is overfitting or underfitting. So let's do that. So I'm going to create a function that will plot and check if we are overfitting and underfitting. So we'll have the plot. So we take in the training data, training label, test data, test labels, and the threads. Then we do the plot. And plot the spreads. And let's see what we get. Yeah. So this is the training data that is in the training data is in blue. The testing data is in green, and the predictions are in here. So the model is not overfitting or underfitting, because you can see for most values that we have inside this space, which are the test data, which are for the test data, we are having the predictions being close to them. So I will say the model is good at doing its job. So I think I'll stop there for today. So maybe we can discuss more in the group. Anyone with a question as to my additions, so as to what I've added? So machine learning is quite interesting. So you just have to practice more and more. So I think when we meet next, I'll take over. So I'll take you guys through model deployment. So since we've seen how we can fit our models, so we need something that other people can use. So we are going to use Streamlit, and we are going to deploy these model. Yeah, and I think that's all from my side. So Sylvia, you can come in if we have no questions.
Okay, thank you so much, Joseph, Tony, and everyone who has attended today's session. As you are seeing that it is really very interesting, and once we are done with this project, I think maybe next Friday we will be able to do the deployment. Next project also, we are now looking forward to more guys coming up as volunteers, so that it is true practice that you can easily master it very well, and even be able to perfect yourself. So thank you all for attending today's session. I'll share the recording. I don't know, Joseph or Tony, I hope you are going to share the notebook in the group as well, so that guys can follow. So thank you all, and have a nice weekend ahead. Bye.
Have a nice weekend too. So I'm sharing the notebook just now.